Hello everyone, we are Team Ingenico and today we will be picking up a problem which most brands miss. Support teams are quietly leaking money because policies are applied inconsistently and chatbots only get tested in happy path demos, not against real customer chats. Refunds, replacements, and COD returns get approved or denied unpredictably, and brands have no safe way to simulate thousands of messy adversarial conversations to find where their policies or bots actually break. Havoc Machine exactly solves this. So, Havoc Machine is a synthetic customer chaos lab that stress tests support systems by generating large volumes of realistic adversarial customer chats from a brand's own product catalog and policy docs. It simulates angry, impatient, multilingual customers who try to exploit refund rules, then scores every bot or human response for policy compliance and empathy. So, let's start the server over here. Yes, we are good to go. Now we will directly see what Havoc Machine has to offer. We'll go to the dashboard over here and we would be seeing all the previous results. So let's try creating a new test. So when we create a new test, we have to put which particular uh, chat URL we want to put and the number of parallel executions and the duration of minutes, and we will directly start the test. So what happens in the background is uh, we our system spins up then around three adversarial nodes because we mentioned the parallel executions of three, and when that happens, simply okay, let me restart. I think it went a little out of error. No problem. Mhm. Okay, so the server is up. Let's restart. So let's restart the test. Uh, So we'll directly start the test. Now what happens here is we spin up three adversarial nodes over here, as we mentioned, parallel executions of three. We can spin up to five in the free tier for this one, and up to 10 for the paid tier. Now what happens is three adversarial nodes are spinned. Now these adversarial nodes in real time are trying to talk with one good agent, and they are trying to bring that down and are trying to exploit its context and its memory and are trying to bypass its rules and laws. And that way, all the conversation that goes on between the bad agent and the good agent, so that gets logged over here, that gets shown, and what we get to see at the end is a detailed analysis of each particular response and where it went wrong, where particular hallucinations or jailbreaking was detected, or we could caught him off the guards, and where it bypassed its existing policies, where it answered inconsistently. And after the duration mentioned, which was one for this particular demo, we will be processing all the test results and analyzing what could have been better and try to build a comprehensive report out of it. And once we are done building a comprehensive report out of it, we try to figure out what could be the patches or solutions for these, and try to inculcate that into our report too, and show the report to the customer. So all the analysis is being done, and yes, we have got our report. So when we click on our report, we directly get to see our consolidated report that's over here. So three sessions were started. So these are the session IDs. So these are the number of vulnerabilities that were found, and these are the average duration. And here we also show there is average response times and all, and the latency, the median, the percentiles, and also if the API decreases or the API degrades during the stress testing. So here the API degraded by around 11% after this test testing. The number of queries, the amount of uh, tokens used for this. So the throughput is quite good. The tokens used is quite less for this kind of a testing. And these were the different vulnerabilities or loopholes that were detected in our particular test. And these all the vulnerabilities are listed over here, from 1 to around we have 9 vulnerabilities. Yes, and then the recommendation, these is basically the patches that can be applied so that this particular problem does not appear again. And if these are actually inculcated, in that case, we like the system would be more tolerant and would be more better or more safer for people to use. Now we also have JSON logs over here, like yeah, the logs. and we would be able to directly get uh, S3 URL, which directly would show all the different logs that are present over here. Now these are a very verbose logs, so and it's very easy for debugging. So developers can actually find out where they went wrong. And since it's mostly built for companies and testers, and anyone can run it from the client as well, but for developers it's most convenient to actually run it from the CLI. So apart from this server, we have also built a CLI tool where we can simply write bash, and we the entire stress testing can be done over here. So these are the presets, and we can enter our own values. Let's keep the duration of one, and the session parallel session has already started. Let's see how it looks. So again, very similar to the UI part, but again it's running totally on the CLI, so no need of opening a browser, no need of visiting a URL, logging in and then checking the logs, or trying to stress test an API. So but yes, here we truncate the responses so that we can show more mode of data, and then all the different conversations that are going on in real time are will stack up over here, and we can see the elapsed time over here, which is of 38 seconds. Now we have set the stress testing time of 1 minute, and for processing the results and putting it on appropriate CDN servers, it takes around 30 seconds more. So this test roughly, a 1 minute test will take around 1 minute 30 seconds for the entire process to complete, which includes the report generation and the patch generations. So yes, the stress testing part is complete. Now it will directly start with analyzing the logs. So yes, it's analyzing the logs at the moment, one of the messages, and we can, let's quit this and let's wait. So it is waiting for the sessions to complete, and once it's done, it's around 5 seconds are remaining. Once it's done, we would directly get an URL to um, the the direct log URL, so it can be directly accessed. So we can simply click, and in case we want to view the report, we can simply we would be able to view it inside of the CLI, inside of the Nano editor. So it's easier for us to go through, debug, edit something, and find something out of it. And in case we want to see the JSON logs, we can simply click J, and in that case all the different logs would open in the uh, already preset editor. It is also configurable. So the CLI tool and the client tool that we have built actually makes this entire application very useful, and all the reports and logs, everything. So this was the log we run on the client, and the ID is ending with EC. So we'll quickly refresh this and see. There should, yes, EC is now in the second, and this particular one, 5E, this one we have run by the CLI. And these are the stats where the total tests, the number of agents spawned till date, and the statuses, everything gets updated. And this has a huge benefit on your market fit, as it reduces the revenge leakage by catching all the loopholes before real customers actually exploit, and it also hardens the chatbots on playbooks by testing them under realistic stress tests of curated demo. And it also standardizes the support decisions so that agents are actually replying on a very similar note, and it also speeds up the policy iteration with concrete data driven rewrite suggestions instead of vague customer experience advice. So that's Havoc Machine for you. That's the difference it makes. And for building this tool, we have explicitly and extensively used AWS technologies, including the Kiro, the entire Kiro agentic modes that we have over here. We have quite extensively used that, and also we have deployed this entire thing on AWS under a subdomain in EC2, and also as showcased, we are also making use of the S3, and all these APIs that we have built, and we have used Requestly to test all the different APIs that we have, and it has been quite helpful for the API testing purpose. And at certain places we had some optimizations, or rather I would say discrete automations, which we built with the help of na10. That's Havoc Machine for you. Thank you.